This is AP Calculus ABA, Unit 7, Applications of Derivatives, Lesson 2, the Mean Value Theorem. This is one of two major theorems that are typically given by letters. We had already the Intermediate Value Theorem, the IVT. This is the Mean Value Theorem, the MVT. Okay. The Intermediate Value Theorem, you recall, stated that on a given domain from A to B, where f of A was the output at A and f of B was the output at B, that every output between f of A and f of B exists on the interval from A to B, right? If that makes any sense, right? The mean value theorem says this. Let's say we have a function defined on an interval from A to B. Okay, so defined on an interval from A to B. Okay, where this is f of A and this is f of B. Okay, and the function can do literally anything along the way. Let's say it does that in between. Okay, we can find the slope of the secant line as the slope of the line between f of A and f of A and B f of B. Okay. So the slope of the secant line is f of B minus f of A over B minus A. Formula that you're quite familiar with by now. Okay. What this says is that on the interval from A to B, there exists a C such that a C on A to B, and I think that's actually for now. I won't worry about it. The C on A to B such that the derivative at C equals f of B minus f of A over B minus A. Okay? In other words, we're saying the derivative at some point on the interval is going to be equal to the slope of the secant. The instantaneous slope somewhere is going to be equal to the slope of the secant. So it's going to be parallel to the secant. Now, the way I've drawn it, it actually occurs twice, but we know that it must occur at least once. And in this case, here's one value of C that is guaranteed by the mean value theorem. The mean value theorem. Okay? So the derivative, instantaneous derivative, some point on the domain is going to be the same as the slope of the secant. All right, so let's apply this here and see what it means in a particular case. All right, so let's say we have the function f of x equals x cubed. Okay, something simple. On the interval, closed interval from 1 to 2. Okay. We might ask, what is the value on the interval 1 to 2 that is guaranteed by the intermediate value theorem for f of x equals x cubed? Okay. First of all, I'm going to find f prime of x, 3x squared. Okay. I'm going to find f of 1, that's 1 cubed. I'm going to find f of 2, that's 2 cubed, or 8. All right. And so the formula for the intermediate value theorem says f prime of C equals f of B minus f of A over B minus A. So f prime of C is 3c squared, and f of B is 8, and f of A is 1, over b minus a, which is 2 minus 1. So 3c squared is 7 over 1. Okay. C squared is 7/3. And c is plus or minus square root 7/3. Now, which one is on the domain from 1 to 2? Well, 1 squared is 1, and 2 squared is 4. This is going to be between 2 and 4. Yep, it is if it's positive. So square root 7/3 is the one that is guaranteed. Okay, let's go ahead and do it just to graph it, just to verify the results here. See if we can visualize this. All right, so f of x equals x cubed from, for x equaling or being between 1 and 2. Okay, and so there's our graph, and we have c equals 7/3. So x equals 7 square root 7/3. So that's the point guaranteed. Okay, and let's change the graph here a little bit here so we can see it a little better. X-axis, let's go x-axis from 1 to 8. Actually, so x-axis, my bad, 1 to 2. Y-axis from 1 to 8. And then zoom out a little bit. There we go. We get a better picture. Okay. And x equals square root 7/3 seems to be the point here. Let's graph the secant line. Y minus, and the secant line, y minus the y value. So y minus 1 equals the slope. The slope is 7 over 1. So 7. X minus the x value. There's our secant line. And our tangent line is going to be y minus the y output from y. So square root 7/3 cubed. I'm kind of piecing this together a little bit here at a time. Cubed. Y minus the y value equals the slope, the same slope, 7, x minus the x value, square root 7/3. And there it is. Okay, so we can see that the purple line and the black line are parallel, and it is tangent at that point. So the slope, instantaneous slope, is parallel to the secant at that point. All right, so probably a little bit overkill there.